Hi everybody, in this video we are going to discuss about locating an element in a linked list using C++. So what is the thing is, we will be given a linked list something like this and an element. So the input for the operation are going to be the list and the element. It is basically search operation. So the list in which we are going to perform the search as well as the element what we are going to search will be given as the input. And the first step of the algorithm will be if the list is empty, right? If the list is empty, then we are going to return -1. That will be the first step. And in the second step, what we'll be doing is we will be initializing a temporary pointer. What we can do, we can initialize the temporary pointer to point to the first node and also the counter. Why do we need a counter is, if the element is found, then we have to return the position in which the element has come. For example, if you are searching for element 7 in this list, then the algorithm should return 3 because it is in the third position. So it should return 3. And for example, if you are searching for an element which is not present in the list, for example, I am searching for 18, right? 18 is not present in this list. In that case, I expect the algorithm to return -1. Okay, so I need a counter, and that counter will be initialized to 1 because it is indicating the position of the temp, right? And temp is initially pointing to the first node, and I am having the counter as 1. Okay, and let us write the algorithm like while temp is not equal to null. What I mean is, I am going to make the temp to move to the nodes in the linked list, and till it doesn't go outside the linked list, right? Till I go beyond the last node, I'll be doing something. What I'll be doing? I'll be checking whether the data part of the node pointed by temp is equal to the element what I'm searching. If it is equal to the element, then I can return the counter, right? Otherwise, I'll be moving the temp to the next node, and also I'll be incrementing the counter. This is what I'm going to do. For example, I'll be having counter as 1, and I tell temp equal to temp next and counter equal to 2 because 7 is the element what I'm searching for. The element here was 10, so I move here, and here also I check whether this element is equal to 7. No. So I'll be moving to the next node, as well as I'll be incrementing my counter. When my temp is in this particular node, the data part is equal to the element what I'm searching, right? So I will be returning 3. Okay, this is the thing that what we are going to do basically. So let us formulate as an algorithm. The first step tells whether to check whether the list is empty. If the list is empty, then we are going to return -1. Otherwise, you are going to declare a temporary pointer temp and an integer counter, right? And you are going to initialize the temp to the first node and counter to 1. That is, we are initializing both, right? Actually, this counter will be keeping track of the position of the temp. And while temp is not equal to null, we are going to repeat the step number 5 and 6. What does 5 and 6 tells? Step number 5 tells you have to check the data part of the node pointed by temp, and if it is equal to element, then we are going to return counter. Otherwise, we are going to move temp to the next node, and we are going to increment the counter as well. Okay, and if I am coming to step number 7, if my algorithm or my code is coming to step number 7, that indicates that the element what I am searching for is not present in the list, right? So in that case, we have to return -1. That's how we are going to indicate failure, as the objective of the function is to return the position of the element, and position is not going to be negative. We can use this -1 for indicating failure. Now let us try to implement in C++. So the first thing is, I have to declare the function inside the class. Return type is going to be int, and name of the function is locate, and the element what I am going to search is also int, basically because this is a list of integers what I am working, right? So let us go and implement the algorithm. Int list, okay, and locate you can tell, and here is going to be int element what I am going to search, right? So what is the algorithm tells? If the list is empty, right? How will I know the list is empty? If is empty is enough, right? If is empty is true, then I can understand the list is empty. In that case, I will be returning -1. Otherwise what we are going to do is we will declare a pointer, and also you'll be declaring a counter integer, right? And you initialize the temp to the first node, that is head, and then counter is equal to 1. Okay, and what does the algorithm test? While temp not equal to null, right? While temp not equal to null, what should we do? We should check if the data part of the node, right? If the data part of the temp node is equal to the element, then we will be returning the counter. Okay, otherwise what should we do? We should increment the counter, and also we have to move the temp to the next position, that is next node. Okay, temp equal to temp next will serve the purpose, right? So if you are coming outside the loop, what does it mean? The element is not found in the linked list. In that case we will be telling -1, return -1. This will be the locate function. Hope there is no error. Let us check it. And I have returned the main also. In the main, what we are doing, we are having 4 insert operations, and then we are going to call locate. So let us try to visualize how the list will be looking like after these 4 insert operations. This is as usual what we are doing. So the first element that is inserted is 1 using insert beginning, and then you are calling again insert beginning and you are inserting 2, right? And then you are calling insert end and 5, insert at the position 10, right? So the list will be having 4 elements like this, and you will see 2, 10, 1, 5. This will be the order of the elements, and then you are calling locate 2. Okay, so when I call locate 2, I expect it to print the position as 2. You see the code, we are checking the return value. If the return value is -1, then we are printing element not found. Otherwise we are printing the position of the element. Let us compile and check the code. So I have used printf, that's the error. Let me correct it. It's C++ code, so I should use cout. We can use even printf if I include stdio.h, but now I am going to use cout. Okay, now the code contains cout. It is getting replaced. I replaced the printf, right? So it's looking fine. Let us try to compile. Yes, we have got rid of the errors. Now let us try to execute it. Okay, so actually we were searching for the element 2. It is present at the index 1. Fine, right? Let us next check for the element 10. Okay, so where is 10? 10 is present at the index 2. Yes, it is printing 2. Next we will search for the element 5. Element 5 is present as the last element. It is at position 4. Let us try to compile, execute. Yes, the element is at 4. Now what we will do is we will try to locate an element which is not present in the list. Let it be 50, right? 50 is not present in the list, so my code should print that element is not found, right? Everything is working fine. Please check the code in the GitHub and also practice by yourself. Thank you.